I'm going to tell you, if I write this, what does it mean?
Us is 21.
Us, that's a 5.
The fifth term is 21.
The fifth term is 21. Okay, that's what I mean. Us is 21. Okay, this is a 5. The fifth term is 21. So you're being given some information. Then what I might do is say the sum, of the first 5 terms is 90.
But what do you mean 5?
5 what? Just leave me alone. All right, find the 12th term. So what I'm going to do, I'll just write out that formula again. So the sum of the series is n over 2, 2a plus d n minus 1. Okay, so what I need to do is I need to work out what do you think I know? What information do I have? Okay, let's do this. Okay, so let's use this information here. If I know that, so let's go back to our normal arithmetic sequence. So really we're just using a plus n minus 1d, right? If I know this, how do I say 21 equals what? What do I do with this information here?
Yeah, this is
A plus what? Good. Why is it 4? Right. So n is 5. This is the fifth term. So 5 minus 1 is 4. So this is 4d. Now this is still unsolvable, isn't it? Right. I've still got 2 unknowns. But what I can do is do a very similar thing with this and get some simultaneous equations. So I know the sum of this is 90, don't I? I know that n is what? 5. So I've got n is 5 over 2. Ooh, you know what? That should be 6. That's going to make this a lot easier. I was like, oh, why am I getting fractions? Okay, so then I've got 2a plus d. What's this? It's 5. Why is it 5? Right, 6 minus 1. So this is 5d. Okay, so then let's do some, what's this number here? 3. So let's make that 30, bring it across and divide it. Then I've got 2a plus 5d. Okay, now I have 2 simultaneous equations. Can't I solve this? I'm going to move that up here so I've got some more room. Yes? No, that doesn't, no. Yeah, L is this whole thing. All right, and then we've got 2a plus 5d. Okay, can I solve these simultaneous equations? What do I have to do before I can solve them? Yeah, so what am I going to do? Double the first one, right? The easiest thing is to double the first one.
Yeah.
So I've got 42 equals 2a plus 8d. And then I've got 30 equals 2a plus 5d. Am I going to add or subtract them? Subtract. So then I get 42 minus 30 is 12. This is 0. This is 3. So d is 4. Whoops, I wrote 3 instead of d. D is 4. Now I can go back and find out a, can't I? So if 21 equals a plus 16, right? 4 times d, d is 4. So then what's a? 5. Okay, so now I have a and d. I have my rule. I can find the 12th term, can't I? Woo! Oh my goodness. This topic doesn't work with your generation, does it? Sigma. Yeah, that's true. It's not you guys, is it? All right. So let's work out the 12th term. If we know that this is our rule, right? So u of n is a plus d n minus 1. And we know all this stuff, right? So the 12th term is a, we just said is 5, plus d, we don't, well, we've got 4. And then n minus 1, n is 12 because we're looking at the 12th term minus 1. So we've got 5 plus 4 times 11. So the 12th term is 49. So sometimes you need to find a lot of pieces of information, but always with these questions, what do I know? What can I start with? And then if you end up with multiple unknowns, that should be your cue to go, I'm going to end up with simultaneous equations. How can I find a second equation where I can then solve things? All right, I've got one more example I'm going to do. This one's a lot easier, so that's nice. All right, so I'm still going to tell you some of the terms. So the sum, this time it's going to look much more complicated. Actually, let's undo that. So the sum of the first n terms, so I'm not even telling you how many terms this time, is n squared plus 5n. All right, so let's use some algebra when we're talking about this. We don't know how many terms, but we know what the sum is. So then I'm asking you to find the nth term or the general term. I promise this is actually a lot easier than it looks. Why don't we find the first term? Okay, so what we know is the sum of the terms. So why don't we find the sum of the first term? Because we know the rule for that, right? So we've got, let me write that down again. Oh, actually, well, we know the rule, so we don't actually need the rule. We're using this. So it's going to be 1 squared plus 5, 1, which is 6, right? 1 plus 5 is 6. What is the sum of the second, the first two terms, right? 1 and 2. We're just going to put 2 in instead. So what do I get? 14. Good. Now, okay, is this the second term? No, this is the sum. Good. This is the sum of the second terms. So if the first term is 6, the second term must be 8 because 8 minus, 14 minus 6 is 8, right? The sum of these is that. Do I need to do another one? Nah. But we've got a rule, right? We've already been given more information. So if I did that, like we could do that, whoops, the third plus 5, 3 gives us what? 24. Okay, so that tells us the next one is. So can't we just see that we're going up by 2? See how it didn't actually give us any more information? I mean, you can do that if you want to be confident that you've done it right, but you don't actually need to do that. But I know that any arithmetic sequence is just this, right? And all I'm trying to do is find out the rule. So my first term is 6. My difference is what? 2. So then I've got 6 plus 2n minus 2. So then I've got 2n plus 4. So if you want to do that and just make sure that you're right, you can, but you didn't actually need this third term because you're being told that this is how the sum works. And so you don't need to work out what type of sequence it is. They're giving you that information.